Hello everyone, this is Diveshwari. I am from CACB. Now I am here to explain one of the synchronization problem. It is readers writers problem. Let's see the contents that we are going to discuss now. Introduction to readers writers problem, solution approaches for readers writers problem, types of readers writers problem, and challenges with readers writers problem. Introduction to readers writers problem. In readers writers problem, what we consider is a database that is shared among several concurrent processes. Let's say we have a database that contains different kinds of processes that is shared among different processes, and some of these processes may only wants to read the data, while some other processes may wants to both read and write the data in the database. So when we have a database that is shared among different processes, then these processes concurrently may wants to read or write to the data in the database. The processes that only wants to read the data in the database are called as readers. That means these reader processes will have only access for reading or viewing. They cannot be able to make any modifications to the data in the database. Such processes are called as readers, whereas the processes that wants to update the data in the database are called as writers. Writers will have the access to make changes to the database, and as well as they can also read the data in the database. Such processes are called as writers. We differentiate between readers and writers by referring formers as readers and laters as writers. So what is the problem in this? Let's see. Let's say we can classify this readers writers problem in four cases. That means, let us consider a reader process is accessing the data in the shared database, and then simultaneously another process also requested for the database. Then and that requested process, if the requested process is also the reader, then both the reader process can read the data in the database without any difficulty, because both are just reading the data. They are not making any changes to the data, so there won't be any difficulty in that. For example, if there is a only one book and two friends are there, they have to read the data, then they can read the data from the book without any difficulties, right? In the same way, two reader process can access the shared data without any problem, whereas when the reader is reading the data in the database and the other process also wants to access the shared database, that means that second process, if we consider the second process as writer process, then there will be some difficulty, because reader is reading the data while writer is trying to make changes to the data in the shared data. They are sharing the same database, and reader process is trying to read the data while writer is trying to make modifications. So in that case, reader will not be able to grab the exact data in the database. So there will be a problem. Same goes with the writer and reader. The first process is writer, and it is trying to make changes to the data in the database, where a reader is trying to grab the information from the database. So it will not be able to get the exact data in the database. So there will be inconsistency. Whereas in the fourth case, if a writer is making the modifications to the shared database, and the other process that requested for the critical section is also a writer, then both are here trying to make changes to the same database simultaneously. So it will be inconsistent. Both cannot be able to make changes to the shared data, to the same data simultaneously. So these are four cases in of the readers writers problem, in which we have problem with the three cases while one is exception. This type of problem in synchronization is called as a readers writers problem, because several processes are trying to modify or access the data of the shared database simultaneously. When critical section, you know the critical section, right? Critical section is a part of a process where the process is trying to make modifications on common variables. And critical section problem is allowing only one process to enter into the critical section is called as critical section problem. Um, to make sure that these difficulties won't arise, we should give exclusive access to the writer process. So whenever the writer is making modifications to the database, shared database, then no other process should allow to enter into the critical section. Either it may be reader or writer. When writer is performing some operations in the database, reader or writer will not have any entry into the critical section. Um, Let's see if we can solve this by writing a code using semaphores. Semaphore is a variable which whose initial value is 1. So in this, to write the code in such a way that these problems won't arise, we have to consider two semaphores. One is mutex and another one is write. Both are initialized to 1 as they are the semaphores. And another variable is the integer value, which is the read count. Here we use the mutex to update to make sure that the read count value is not updated simultaneously. Whenever we want to make changes to the read count, then we'll get hold of the mutex so that no two processes will be simultaneously able to update the read count value. And a write semaphore is a shared data here for both reader and writer. It is most responsible for writing. And the next one is integer value. It is a read count, right? Read count integer value, it is initialized to 0. It keeps the track of how many processes are currently reading the data in the database. Let's see the code for the writer process. Here, do while loop, we use the do while loop. Whenever the process that is requested for the critical section is a writer process, then this condition becomes true. Then we have to this code will be executed. Here, wait write. Whenever the writer process requests for the critical section, then we have to get hold of write. We also know that wait means we are decrementing the value of write by 1. So initially write value is 1. So by getting hold of write, no other process will be able to enter into the critical section. No other writer process will be able to enter into the critical section when we get hold of write until it releases a write variable. So by getting hold of a write semaphore, the writer process will perform the write operation in the critical section, and after completion of the operation, when it wants to leave, it releases the write semaphore by executing a signal. So signal of write means signal means we have to increment the value of write by 1. Whenever the value of write is 1, then other processes can enter into the critical section. Whenever the write variable semaphore value is 0, that means the critical section already contains one write process, so no other write process will be able to enter into the critical section. So after completion of the performing write operation by the process, while it leaves, it signals a write. That means it releases the write variable so that the other process can get hold of it and enter into the critical section. This is the writer code, and the reader code is this is the reader code. Um, in this reader code, this is the reader code. In this reader code, whenever the process that is requested for the um, critical section is a reader, then this code will get executed. Here first we are whenever the reader process request for the critical section, here we are getting the hold of mutex. As I said, whenever we want to uh, update the read count value, we have to get hold of mutex, right? So we are getting hold of mutex semaphore. By getting hold of mutex semaphore, we will decrement the value of mutex to 0. That means when we get the hold of a mutex, no other reader process will enter and cannot make changes to the read count. When we get hold of a mutex, then we can update the read count value. As one reader process entered into the critical section, we should increment the read count value to 1. So here read count plus plus means read count value will get incremented by 1. And then if read count equals to 1, here we are checking the condition to make sure that the critical section contains at least one reader process. Then if it is true, then we should eliminate the entry of a writer process, right? So to eliminate the entry of writer process, we are again getting the hold of write, so that until this the right way semaphore gets released, no writer process can get hold of write. So here weight of write means write value becomes 0, and that means no writer can enter into the critical section until this gets released. So again, we are releasing the mutex. We are releasing the mutex means, as I said, if there are two reader processes in the critical section, there won't be any problem. So we can allow other reader process to enter into the critical section. So here, that's why we are releasing the mutex. If we release the mutex, then its value will incremented as we are executing signal. So its value will get equals to 1. So other reader process can also enter into the critical section to perform read operation. So here it is a critical section. After performing the read operation, whenever the reader process wants to exit the critical section, then again it should decrement the read count value, right? So to update the read count value, we should get hold of mutex. So weight of mutex. Here weight of mutex, that means again we are getting hold of mutex, so that read count value will be decremented by 1. Read count value is decremented by 1 as the reader process is leaving the critical section. And if the read count value is equals to 0, that means in the critical section, if there is no reader process, then we are signaling write. That means we are incrementing the value of write. That means we are releasing the write semaphore so that other writer process can enter into the critical section. When this code will be executed, if the critical section does not contain even at least one reader process. If the critical section contains a reader process, then just we are signaling mutex, that so that other reader process can enter. Will release the write variable semaphore whenever no reader is present in the critical section, so there won't be any problem. So this is the reader code. This is the reader code. And solution approaches for a reader writer's problem. Several solution approaches have been proposed to solve the reader's writer's problem. One of the simplest solutions to give exclusive access to the writers and allow multiple readers to access the resource simultaneously. This approach ensures that no two writers can access the resources at the same time, preventing any race conditions. Another solution approach is to use a semaphore or a mutex to synchronize the access to the shared resource. In this approach, the threads acquire the lock before accessing resources and release it once they are done. This ensures that only one thread can access the resource at a time. Types of readers writers problem. There are two types of readers writers problem. The first type prioritizes readers over writers, while the second type gives equal priority to both. In the first type, if a writer is waiting to access the resources, no new readers are allowed until the writer has finished. No thread starves. One way to achieve this is to use queue to manage the request of the shared resource, ensuring that each thread gets a fair chance to access it. And let's see how we can solve the readers. Four cases we have. No? Let's see how this code will work with that four cases. See here, if the process that is requested for the critical section is writer, then here write value becomes 0 after performing its operation, and write value becomes 1 while performing the write operation in the critical section. If the process, another process also requested for the shared database, and that process, let's assume that process is a reader process. So reader process, right? Whenever the reader process wants to enter, we should get hold of a write variable, right, to allow the reader process. But in this writer code, the writer process already get hold the held the right semaphore. So until it releases its right semaphore, no other reader process can enter, because it can get hold of right whenever the right operation, whenever the right process is getting um, hold of right. So when one writer is performing a write operation in the critical section, no reader can be able to enter into the critical section, because a write variable, a write semaphore is not available. And whenever the write, if we say when a writer is performing a write operation and other writer process wants to enter into the critical section, then it cannot get hold of write semaphore, because already one process held at the right semaphore. Until that process releases the right semaphore, no other writer process can enter into the critical section. So in this way we can solve the problem for the writer process. And when it comes to reader code, here if, let us consider if a reader is performing a read operation in the critical section, and the process, the second process that requested for the data, shared a database, is a writer. That means here a reader process already get a held for write a semaphore. So the writer process cannot be able to hold the write semaphore until this reader process releases it. So there is no chance of a writer entering into the critical section while one reader is performing its operation in the critical section. So we have solved a reader writer, writer reader problem. And when in the before we have solved writer writer problem, and now reader reader, there is no problem. Let's see how. When a reader process is reading the data in the critical section, and it gets held off right, and it is releasing the mutex variable, mutex semaphore. So the writer process can get held of a mutex semaphore and can increment the read count value. So there will be no problem of entering more than one reader process into the critical section. This is how with this code we can solve reader writer, writer reader, reader reader, and writer writer problems easily. And challenges with the reader's writer's problem. The reader's writer's problem can be challenging to solve because it requires balancing between concurrency and mutual exclusion. If the solution approach allows too many threads to access the resources simultaneously, it may cause race conditions and inconsistent data. On the other hand, if the solution approach is too restrictive, it may lead to starvation and decreased performance. Another challenging is to ensure the solution approach is scalable and efficient. As the number of threads accessing the resources increase, the solution approach should be able to handle the load without causing bottlenecks or deadlocks. In this way, by writing the code for a reader and a writer code, in this way we can solve the reader writer problem. I hope you understand. Thank you.